All right, let's resume. I checked with them on Slack. We should be good. So, go over the spec again. We're going to take in some arguments that are all integers. Can be any number of integers. We're going to add them all together and output the result. That's the phase 1 of the project. You should be able to do that one with pretty much everything we've talked about so far. And the phase 2 requires you to learn a little bit that I haven't talked about. So we'll see how many of you have made it all the way to phase 2. I'm going to give my answer to this exercise, and then we will break for lunch. So although we're 1 minute short of noon, I'm going to go over just a few minutes, but if you're starving, don't worry, we'll be going to lunch shortly. But let me give my answer to this one. So I'll just start with one of my new console apps. There we go, there's one that just has a read key. So the very first thing we do, we already know what our input parameters, right? Let's set up the input parameters immediately to make sure we have a good example we can press F5 and run and test. Don't forget to set a startup project if you're trying a new project. So I'm going to go to Properties and Debug and give myself the example data, 1 space 2 space 3. Our hope is to see the number 6 on the screen if I'm really successful. So let's give it a shot. I'm going to leave the read key in there because that's basically our pause command. So the first thing we need to do, when we look at the spec, we could take any number of arguments and we're going to add them all together. So I also said I wanted to be able to tolerate what if there are no arguments. It should spit out a 0, which means we always need the output of an integer. We're not going to get out of that. Let's go ahead and just declare that. Result 0. We're going to start off at 0 because that's a good place to start. Now we just learned about loops, right? And we're going to loop over all those incoming arguments. How do I loop? Anyone? There's 4 ways to do it. Which way should I use? 4. 4 actually works because this is an index. It's an array, and I could access it by index. If you did a 4 solution, that's perfectly fine. I think it's easier to not think about indexes. What's the other one? 4 each. That's the one I would use. If you use the 4, though, you're still fine. If you've got a 6 output on that screen, you're still successful. There's nothing to change. But I like 4 each. That's what I'm going to do. I'm just going to call it I. It is an integer. In args. Actually, it's not an integer. That's a string. Let me just call that. I'm going to call that string value, just because I can. It just makes it easier to read. So I'm looping over all of it. And for phase 1, we're just going to assume that they're all integers. We're not going to handle the zebra yet. Let's just get it working in the simplest way we can first. So how do we convert a string into an integer?
Parse.
Parse. And where are we going to find that parse? What did you say? Int. That's right. I can do int.parse the string value. Oops. If I type it correctly, it will not be read. Right? And I can pause here and just show you where we are. Right, we have a result that's 0 that's currently unused. No big deal. The string value, its type is string. All command line arguments default to string. I use int.parse. This is the int version of the value. So now we've turned a string with the number 1 in it to an integer value of 1. That's good. Then I can do some simple arithmetic. Result equals itself plus the current int value. Spelled correctly. So now we're doing, I call these accumulators. The result value is an accumulator. We're accumulating the correct result as we loop through. Now we're going to loop through all of them, so I don't need to break out of it. I don't need any continues. I don't even need any ifs. Remember, we're doing the simple version of this first. I can right line and I can spit out the result, and I will go ahead and use the toString even though I don't have to. And let me run that, see how that works. Six. So for the phase 1 of the exercise, this works. We've used a few of the techniques we've talked about this morning. So we know how to loop over the arguments. We know how to declare a variable. We know how to increment it by a certain value. We did that via parsing. We did the parsing first, actually. And then we just write it to the console. We use read key as a cheat to make the screen pause so it doesn't flicker when we press F5. So for the first phase, we're actually done. I will show a shorthand just because I can, There is a shorthand in C# for incrementing something, so I could just as easily do plus equals int value. If you've used some other languages, you're used to these easier to type operators, this actually gets the exact same work done. I can confirm that by pressing F5. That plus equals is just like that previous line. Result equals result plus int value. It's just a shorthand. They give us the shorthand in languages like this because it's so common for us to do things like incrementing variables or adding to them. So they give us the plus equals because it's so common. But they are synonyms. Both of the lines before and after I made that change did the exact same work. So I'm going to leave that one because this is the way I would type it, right? The less I type, the happier I am, right? Make the code as small as possible. This gets the job done. So for phase 1, that's the end of the exercise. But there was an advanced version of it, and that was, what do we do when they hand in bad data? Well, the first thing, let's set up the command so that we bad data. Zebra. So now it's 1, 2, zebra 3. I'm going to press F5. This will fail. Now if you did this, you might have seen this. An exception occurred. All right? I'll talk more about exceptions later in the course. Exceptions in C# are dramatic events. As their name suggests, they're not supposed to happen often. Some people just call these errors, but I like to use the proper name of exception. Exceptions, when you're running this in the debugger, it will break at the exception. That means it kind of pretends like it put a breakpoint there for you and instantly pauses the program and attaches to that moment in time. If this were an app that a customer runs, it explodes in their face. They see a giant error message, lots of print on the screen. If that app was called by some other app, it returns a bad error code. Bad things happen. The event log in Windows gets an exception message. It's a really pretty catastrophic sort of ending of your program. It's not elegant at all. It's a complete, everything's broken. And it's breaking for the exact reason we think. It says input string was not in a correct format. It's breaking on int.parse. If we didn't know why it was breaking, we could put the mouse over string value and we see, oh, it's because it's a string named zebra. Well, of course, there's no way to know how to convert a zebra to an int. Like, that's not a normal human thing. How are we going to get out of this? Well, I told you in the spec we can throw out those values. Now, you could have typed, if string value equals zebra, but the problem is I could go back in there and type giraffe and now it would still break. You don't want to try to put all those permutations in. What we really need is a way to say, hey C#, can you try to parse it? And if so, give me that. And if not, just let me know that something went wrong, but please don't throw an exception. Like, you can actually ask that. And that's why I made this sort of a phase to the exercise. I didn't show you how to do this. I mentioned it in passing earlier this morning. I mentioned it real fast. You might have missed it. It was meant to be really subtle. But there are, remember, whenever you're trying to convert to something, check that IntelliSense list. So let's look at just int dot and see what we get. There's a try parse. Let's read the text. Converts a string to a number, specified style and culture. A return value indicates whether the conversion succeeded. Right? It's clearly going to, and you can see the return type on try parse, the very top left of this tooltip, is bool. So it's going to give us a bool. What can we do with bools? Ifs. We can do ifs on them. So let's tweak our code a little bit. I'm going to look at that definition again, and we'll read how it's supposed to be typed. We can pass in the string. We've got multiple overloads, and we have this weird out here. Now, I didn't talk about outs yet, but we're about to talk about them. So let's try that. So I'm going to comment out the line that's not working. If int.tryParse, because we know the tryParse returns Boolean, so we know we're going to, the result of tryParse is the Boolean value we want to evaluate. So int.tryParse, we pass in the string, okay, that's just like the normal parse, so we'll type in string value, out. Now I haven't showed output types, so this was the part that I left out. I was curious if you'd end up Googling this or trying to stumble onto it. We can do out int, I don't want to use result, I want to use int value, that's what I want to use, and create a block for it. Now there's a lot going on here, right? We already know what ifs are. We know that this calling method returns a Boolean, so we're good there. We pass in the string, that's like this original line, but this right here is special. Now we don't use out parameters very much in C#, but the Microsoft put this in version 1, so we do still use it to this day. What we're saying is call that method, pass in our string value. If it succeeds, create a new variable of type int named int value and bring it back out of that method. This is a way to get data out of a method that's not a return type. You won't be doing this often. That is to say, you won't be writing your code to do this often, but there are a few things built in the .NET framework where Microsoft chose out parameters, and that's what we use. There's a long legacy reason why they still exist. The long and short is there are newer features in the language. Remember, it's been around for almost 2 decades. There are new features that preclude the need to ever use out parameters, but they didn't exist in version 1. They didn't exist in the year 2001. It was actually released, I think, January 2002. I got a version in October 2001. That's why I always say 2001. At that time, this was the only way to get out 2 values from a method, the Boolean value and the integer. So for legacy reasons, we're using output parameters here. But I'm going to ask you not to create your own methods that use output parameters. Feel free to do it when you're learning how C# works, but on the job, it's probably not what you want to do. If you can't figure out a different way to do it, ask a friend. Google it, do something. But this is a legacy method. It still gets the job done, so we still use it. So we're going to output the int value. So by the time we end up in the body of this if, the try parse succeeded. Remember, it said in our tooltip, return value, blah, 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 indicates whether the conversion succeeded. So if where my cursor is right now, this is a location of success. What this means is we can increment our value. So I'm going to cut and paste that line right in there. I can increment that result just like I was doing. I'm going to remove the old commented code because I've now fully replaced it. And then the question, of course, is what do we do if the parse fails? Well, I told you in the spec, I kind of made this easy. Don't do anything. So I'm not going to put an else on here. If the parse fails, we just go to the next number. So this is going to be 1, 2, skip it, 3. I should be able to run this, and I should see the number 6. 6. And that is the second phase of the exercise completed. And the skill sets we've used, once again, we've used looping, we've used ifs, we've used a built-in conversion method because we're using a statically typed language. Unfortunately, we just learned what output parameters are. Now you know they exist, but try not to use them very much. And then we wrote the result to the console, which we already knew how to do. That's the end of this version, my version of this exercise. It's not the only way to do it, but this is probably about the most elegant I could come up with at this point. Any questions or comments about my answer to the exercise? Out of curiosity, here in Richmond, how many people successfully by yourself got the first version done, the 1, 2, 3, without the zebra? That's not bad. That's not bad. Okay, cool. Any questions from Richmond? Winston-Salem?
Nope.
I'm in Richmond. Okay, I'm hungry. I think it's lunchtime.
Let's do an hour, so come back at 1:10, whatever.
Let's come back at 1:10. Yeah, 59 minutes. Enjoy.